Hey guys, so I basically wanted to make another transformations video that goes through the different types of transformations, different ways you might see them, different ways you can apply them, visually what happens to your graph when you use them, and basically just do an overall review of transformations. So if you wanted to print out this chart, feel free to. If not, if you're an on-site person, I do have paper copies in the classroom for you to pick up if you would like to grab one there. And I'm just going to basically go through and talk about like tips and tools for remembering which transformations apply where and so on and so forth. Okay, so let's talk about the first ones. Okay, so this section, this part right here, this is all vertical. So these are all things that vertically transform your graph. And you can tell it's vertical because all of the things that are happening, the plus D, the minus D, the multiply by C, the multiply by 1 over C, and the negative multiplication, they're all happening outside of my function. So you see how that's different from over here where everything's inside of the parentheses. So these things are all happening outside of my function. And so that means that's one way to recognize that it's vertical versus this side, which is horizontal stuff. Okay, horizontal. And that's because all these things are inside of your functions, right? You're either adding or subtracting D inside of your function. You're multiplying by C or 1 over C inside of your function, or you're multiplying by a negative inside of your function. Okay, all right, now let's talk about some more clarification stuff. When you add or subtract to your equation, vertically, that moves it up or that moves it down, and that makes sense. So like if I took a function and I just added 4 to it, that moves it up 4. If I subtract 5 from it, that moves it down 5, okay? If we do addition and subtraction inside, that moves my graph left and right. And I like to think of these as being the opposite. They are opposite of what you would normally think. Opposite of normal thinking. So normally I would think that when you add, that would move to the right. But because I'm looking at a horizontal something, a horizontal shift, I'm going to think opposite of my normal thinking. So if you have x plus a value inside of your function, like x plus 2, that's actually going to move your graph left 2. If you have x minus 16, that's actually going to move your graph right 16. And so all horizontal things kind of work the same way, where they're opposite of normal thinking, all right? Vertical things make sense. All right, so that's shifting. Another word for shift could be a translation. So if, oops, oh geez, I keep undoing things. If you are looking for another word for that, it could also be a translation. Okay, either way. All right, now let's talk about stretching and shrinking. So when you do a vertical, oops, let's use a new color. Gold or orange. All right, if you do a vertical stretch, that basically means that if you have a graph, you're grabbing it by the top and you're grabbing it by the bottom and you're pulling it apart. So let's say if I had a graph that was like a parabola or something like that, right? Oops, I'll put an arrow on it. If you're vertically stretching it, that means you take one hand and you grab it from the top, and in one hand you grab it from the bottom, and you're pulling it apart. So your entire graph gets skinnier because you're vertically stretching your graph. Okay, that happens when you multiply by a whole number out front, right? It's outside of your function, but it's multiplication by like 6 or 23 or 2. It's a whole number, okay? If you have a vertical shrink, so if you multiply by a fraction or a decimal that's less than 1, so like 0.8 or 1/3 or 1/4, 0.25, what that does is it takes your graph that you had, so let's say we had like an absolute value graph, and it shrinks it. So you're grabbing your graph from the top and the bottom and you're pushing in on it. So vertically it shrinks your graph, which makes it fatter, but vertically it squishes your graph. Okay, and that makes sense. Horizontally, again, we're going back to this like opposite of normal thinking thing, because horizontally what happens is if I have a whole number inside of my equation that's multiplying, what that actually does is that shrinks horizontally by this factor. So if I have, for example, if there's a 4 inside of my equation, then it would actually be a horizontal shrink by 1/4. And that's because what you end up having is, let's say I had a nice cubic function. If I had a nice cubic function and I have a number multiplying it on the inside, what it's technically doing is I'm grabbing your graph this way and it's shrinking it towards the middle. It makes it squished more this way. So a horizontal shrink by 1/4 if you had a 4 inside of your function, okay? And then if you had, let's see, we did cubic, let's do a higher polynomial function. So we've got a bunch of different bumps. Okay, if I have a fraction that's less than 1 inside of my function and I'm multiplying it, that's a horizontal stretch, because what you're technically doing is you're grabbing your graph here. Oh, you can't draw off the paper. And you're stretching it this way, so it makes the whole graph wider. So if you had, for example, if you had a 1/3 inside of your function, you would have a horizontal stretch by 3. Okay? Again, like, right? So a whole number, that would normally to me indicate a stretch, but for all the horizontal stuff, it's opposite of your normal thinking, okay? Last but not least, before we look at some of the visuals for it, we have our negatives. And so if you have a negative out front, that flips it over the x-axis because that's a vertical flip. So like, for example, if I draw there's my y-axis and my x-axis. Here's my x-axis. If I flip stuff over my x-axis, isn't that a vertical flip? Or I'm flipping it up and down, so I'm flipping it over the x-axis. So I have the negative out front that flips it over the x-axis because it's a vertical flip. If you have a negative multiplying your x on the inside, that flips it over your y-axis, which is a horizontal flip, right? Horizontal, horizon means left and right. Vertical means up and down. So vertical, up and down. Horizontal, oops, blue, means left and right. Well, to the left and right as best as I can, okay? So if you have a negative inside, that's a horizontal flip, a flip over the y-axis. If you have a multiplication inside, that's a shrink or stretch horizontally, depending on whether it's a whole number or a fraction. If you have addition or subtraction inside, that's horizontal shift or translation, either left or right, okay? For vertical, everything if you add or subtract on the outside, that moves it up or down. And this one, vertical, makes sense. If I add a number, that moves it up. If I subtract a number, it moves it down. If you have a multiplication out front, that's a vertical stretch or shrink. And again, that one makes sense because if you multiply by 3, it's going to get 3 times bigger. And then if you have a negative out front, that's a flip. It's a vertical flip, so it flips it over your x-axis, okay? So that's the most, like, condensed version I can give you of transformations of graphs in your equations. There are some more visuals here. So for example, it says if you have functions and you add or subtract on the outside, that moves it up and down. So this is what's happening if you move a graph up and you move a graph down. So that's a vertical shift or translation. If you have a horizontal shift, then that moves it right and left. And then they give you visuals of that as well. A reflection of the graph. Remember, this is what I was saying about the flipping, right? So if I have a negative out front, that's a vertical flip. And so a vertical flip flips it over your x-axis. If it's a horizontal, a negative inside, that's a horizontal flip, and that flips it over your y-axis. Vertical stretching or shrinking. So this is just a fancy way of saying greater than 1. This is a fancy way of saying a fraction less than 1. So some examples that could be here is like 1/3, 0.25, 5/8. Those are all examples of fractions or decimals that are less than 1. If you multiply vertically out front, you multiply it by a factor of c, like they're doing here, right? I took my original function, I multiply it by a factor of c, and c is a whole number, then it stretches it vertically. It's taking my graph and it's stretching it top to bottom, or top and bottom. If you have a c value that's a fraction, so it's like 1/3, 0.25, 5/8, what we're technically doing is we're squishing our graph vertically, so it's going to get squished more like that. And then horizontal stretching and shrinking, this is the one that's wonky, you guys. It's opposite of what you're normally thinking. So if you have a fraction inside, like 1/3 or 0.25 or 5/8, that's actually going to end up being a horizontal stretch. So like here, it would have taken my graph and I would have grabbed it and it would have stretched it this way. As opposed to if you put a whole number inside. So if I did like a f of 8x, that's going to actually horizontally shrink or squish my graph. Okay. All right, I think that's it for this part. I am going to do some examples, but I'm going to have to do them in a separate video. So I just wanted to kind of go through, talk through, and give you guys some ways of remembering inside and outside, the fact that horizontal is always pretty much opposite of what your normal thinking is, and then visually what would be happening with your graph. Okay, so I'll go ahead and we'll do some practice next.